Hi guys, today we're going to look at cross-validation. We'll see how it works, its pros and cons, and an example of its implementation in Python. After you have fit your model and perform the model evaluation, you can then choose to perform cross-validation. Cross-validation is a technique used to increase the model generalization power. It does this by avoiding overfitting. This means that it assesses how the model will generalize to an independent dataset. It is mainly used in settings where the goal is prediction and one wants to estimate how accurately the predictive model will perform in practice. This makes the model not only useful to predict training data, but also to be applied in the real-world data, which is the point of modeling. There are two different types of cross-validation. One, exhaustive types, and two, non-exhaustive types. Exhaustive types of cross-validation methods learn and test on all possible ways to divide the original sample into a training and a validation set. The two methods under this are leave P out method and leave one out method. Non-exhaustive cross-validation methods do not compute all ways of splitting the original sample like the non-exhaustive types, but they are approximations of leave P out cross-validation method. The methods in non-exhaustive cross-validation are k-fold method, holdout method, and repeated random subsampling method. For today, our focus will be on the k-fold of k-fold method. Pros. 1. It gives a better estimate of out-of-sample accuracy because of using different test sets. And 2. It uses the data more efficiently because, as we have seen from the video, every observation is used in the train and test sets. Looking at the cons, the first one is it's not easy to examine results. For example, through the ROC curve or the confusion matrix. Secondly, it can be slower than other methods, for example, the train and test method, since there are many folds to perform. Lastly, cross-validation is not recommended for use with data where the order matters, for example, like in time series data.